As a data scientist who works with both Python and SQL, you're probably looking for faster ways to go from raw data to insights, aren't you? But when you're working in Jupyter Notebook and suddenly need SQL, you end up exporting data, switching back and forth between SQL Server and Jupyter Notebook tools. This is not exactly efficient, right? Well, what if you could skip all that and run SQL queries right inside your notebook, without SQL Server? In this video, I'll show you how to use SQLite, a built-in, lightweight database in Python, to run SQL directly and return clean Pandas DataFrames instantly. This trick has saved me hours in real-world projects, and you can copy and paste it today. If you stick until the end of this video, I'll reveal a bonus trick about date format technique that is only available in SQLite. This is something you won't find in SQL Server or MySQL, and you definitely don't want to miss this. Before we jump into code, let's talk about why I don't use SQL Server or MySQL for everyday data analysis. Here's the simple truth: data scientists are not data engineers. Data engineers are responsible for building data infrastructures, ensuring data moves smoothly, consistently, and securely across the organization. They rely on powerful database tools like SQL Server or MySQL, with user access control, automated backups, and failover support. These tools are essential for production environments where reliability, security, and scalability matter, like powering dashboards or generating official business reports. But they come with a cost, setup, maintenance, and complexity. On the other hand, as data scientist, my focus is analyzing data, building models, and generating insights that matter to business decision. For example, by proving that e-commerce promo can increase additional transactions or revenue by 25% from the existing customers, I can persuade marketing team to increase promo campaign to drive more revenue. As you can see, most of my work is exploratory, much like research and development, done right inside a Jupyter Notebook in Python. The datasets I use are often sampled data pulled from production systems, and they usually fit comfortably into memory. So, utilizing up a full SQL Server is overkill. It slows me down and adds unnecessary friction to my workflow. Let me give you an example based on my experience. During a recent analysis, I needed to create a lagging time element, something like lag function from SQL. I couldn't remember the exact Python code on the spot, but I do know how to do it easily in SQL. If I have to use SQL Server, the approach would consist of exporting the data, uploading to SQL Server, running the query, exporting results, importing back into Python Jupyter Notebook. Just thinking about it makes me tired. I want to finish my job, present the insights, and go home on time. That's when I turned into SQLite, a built-in Python tool that lets you run SQL queries directly inside a Jupyter Notebook. There's no server, no setup, and the results flow straight into a Python data frame tables. I can fully utilize the SQL command that I'm most comfortable with, without ever leaving my Python environment. I'll show you exactly how to set it up and use it easily. Now, let's use the simple Python script to connect SQL to Python in Jupyter Notebook directly. Feel free to copy this script. I've also included it in the description box of this video. This following code is used to run SQL query by connecting to external database, called database.db, from SQLite. Basically, we let the SQLite handle the data processing instead on the Python. Python just sends the command and receives the results. To make this work, we'll use the SQLAlchemy library, which makes it easy to connect Python with a database and run SQL commands. The create_engine function sets up a connection to the database.db and then pass that connection into a helper function, called query_from_db. The SQLAlchemy library import a text function that can be used to handle raw SQL statements. The query_from_db function takes a SQL query string, like select asterisk from users, and a connection engine, runs the query, and fetches all the results back into Python in the form of Pandas DataFrame. Let's explore one by one. This statement 1 opens a connection to our SQLite database with engine command as well as using string1, that is the SQL query input, that has been converted into text object. Think of it like saying, "Hey database, I'm ready to talk to you now," and we expect for database to give us the answer. Now, we take all the rows returned by the database and put them into a Pandas data frame. This makes it super easy to view and analyze the data in Jupyter Notebook. Finally, we add the column names to the data frame. This makes our table readable, just like naming the columns in a spreadsheet. As you can see, this code will save you a ton of time because you don't have to do any manual exporting or importing. All you need is your raw SQL statement, and Python takes care of the rest. By the way, if you like this video content, please consider subscribing my channel so that you won't miss from my future videos about tips on how to succeed in data science for business world. Feel free to drop comment below and I'd be happy to answer. Okay, let's continue. Now, let's walk through a real example of connecting SQL to Python using a Jupyter Notebook. At the top of the notebook, I define a query function that takes a SQL string as input, to be processed and returned as Python DataFrame. As mentioned earlier, this function allows us to run SQL directly within Python. Don't forget to import the necessary Python packages, SQLAlchemy for managing the database connection and Pandas for handling and analyzing the data. While SQL handles the querying, Pandas is still required for performing basic data cleansing tasks that don't require complex transformations. For example, using Pandas, I can import a dataset stored in CSV format and make it readable in Python. I can also convert a column approved date into the correct date-time format using the to_datetime function. If you take a look at the raw data using the info function, you can see that the approved date column is now properly recognized as a datetime object. Before performing advanced SQL operations in a Jupyter Notebook, we first need to upload the Pandas data frame into a SQL database using the to_SQL function. In this case, the table name is set to raw_data, which will be the name of the SQL table created. The engine parameter specifies the SQLAlchemy engine that handles the connection to the database. The if_exists is set as replace, and it ensures that, if a table named raw_data already exists, it will be overwritten with the new data. Now, let's explore the complex data manipulation using SQL and Python. Basically, you just write typical SQL statement as character. The purpose of this SQL query is to analyze customer loan product ownership, whether single versus multiple loan product owners, by identifying which loan products each customer has, and how many total loan contracts they hold. It produces a final table that shows whether customers own products like motorcycle, car, electronics, or new motorcycle, along with their total number of loan contracts. To make the logic organized and easier to manage, this query uses a common table expression, or CTE, named as reference. The CTE works in several layers. First, it counts how many contracts each customer has, for each product. Then, it pivots the data to create one row summary per customer, with each product as a separate column, or transforming from long to wide. Finally, it converts the product counts into binary flags, 1 or 0, to indicate whether the customer owns each product type. This structured approach helps prepare clean data for the final classification step. In the main part of the query, we calculate the total number of contracts each customer has, regardless of product type. Then, we join this summary with the CTE to combine overall contract count and product ownership. The last step adds a simple business logic rule. If a customer owns more than one type of product, they are labeled as a multi-product owner, otherwise, they are labeled a single product owner. This analysis is useful for identifying cross-sell opportunities, understanding customer profiles, and making data-driven business decisions. Therefore, you just need to put the entire SQL query script inside this query_from_db function as previously written on top of the Jupyter Notebook. As you can see, the output has been transformed automatically into Pandas data frame, and you don't have to worry the work from Python to SQL and return it back to Python. All will be taken care by the formula. Okay, here's my promise for the bonus chapter on handling date formats in SQLite. In traditional SQL databases like SQL Server, calculating the difference between two dates is typically done using the datediff function. For example, to find the number of days between January 1st and June 23rd, 2025, you would use datediff function from initial date and final date, producing 173 days difference. However, SQLite doesn't support the datediff function. Instead, you achieve the same result using the Julian day function. By subtracting the Julian day of the earlier date from the later date, SQLite returns the exact number of days between the two dates, which is also 173 days. Now, do you want to discover how data scientists use SQL to actually drive real business growth? In the next video, I'll break down powerful SQL intermediate concepts, like CTEs, window functions, and joins, with a real case study that helped boost sales revenue. Click now to dive in.